everyone, welcome to ACE Online. So in this session, we'll be discussing your revision series aspect for the subject, steel structures, and we'll be discussing some of the previous year questions and some similar questions also in our today's session, specifically focusing on your subject, steel structures, right? Now consider this session as a benchmark session so that you can have an idea of the level of questions which are asked in design of steel structures subject, right? Now the number of questions you can expect from this particular subject is 7 to 8 questions out of 100 questions in your CBT-II examination. The level of questions which are asked are similar to that of SSC JE only and other junior engineer level examinations. Not heavy concepts will be asked from this particular subject. Mostly the codal provisions and some simple fact-based questions will be asked from this particular subject. So let's dive into the questions directly and see some of the examples of those questions, right? Consider this session as a example session only so that your preparation is kind of relating to these kind of questions only. Right? Don't get too much deep into the questions and concepts like GATE exam or engineering services exam. Yeah, simple level of engineering services questions which are asked before 2010, they can be considered. And in RRB JE also, you can expect, you must have seen until now, if you are preparing well, that some previous year engineering services questions are also asked sometimes. So simpler questions of engineering services you can still do, right? If you want to get better with your preparation. So let's see, the BIS code which deals with the steel structures is, so BIS 800, Bureau of Indian Standards 800 codes. There are two, IS 800 2007. It is primarily for the newer version of code, which is focusing on limit state method primarily, and IS 800 1984, which primarily focus on WSM and also the plastic method design, right? Apart from that, BIS 456, it is for RCC structures, design of RCC structures. 875, it is for loads, it has 5 parts. And BIS 1893, design of earthquake resistant structures, right? Next question, let's see, according to IS 456, the modulus of elasticity of steel. So specifically in this question, they're talking about the reinforcement aspect of the steel, right? In general, for steel structures also, when we consider standard steel material or standard structural steel, the modulus of elasticity, that is ES, it is equal to 2 into 10 to the power 5 Newton per mm square. For higher grades of steel also, you can expect the same modulus of elasticity. If I want to represent modulus of elasticity on stress strain curve, so consider stress on y-axis and strain on x-axis. So various grades of steel, structural steel with respect to the carbon content when we consider that. So this is your low carbon steel stress strain curve. After that, this is medium carbon steel, and the topmost will be the high carbon steel. The modulus of elasticity is the slope at the origin for the curve, which is actually same for all the three, right? So this is equal to nothing but 2 into 10 to the power 5 Newton per mm square. So this is your low carbon steel. This is medium carbon steel. And this is high carbon steel. Right, this is high carbon steel. So you can consider all these three kinds of steels. Over here, this shall be your answer, 2 into 10 to the power 5. So you can convert this into MPa. Your answer would be same. Apart from that, let's see this next question. Mild steel is used in the manufacturing process of rolled steel sections, right? It is one of the ways actually. Rolled steel sections are the sections which are fabricated in rolling mills, right? In rolling mills, you would consider molten state of steel ingredients, steel composite materials, and you would pass them through series of rollers, and pressure would be applied, and you can turn out different shapes of steel sections. Mild steel is one category of steel which can be used for rolled steel sections. There can be medium carbon steel also and high carbon steel also. Mild steel is nothing but low carbon steel, right? It is a form of low carbon steel only, in which carbon content is close to 0.23%. So mild steel, or in general, you also regard it as standard structural steel. This is a kind of steel which generally has a carbon content of 0.23%, right? 0.23%. There's a carbon content. It is as per IS 2062, standard structural steel. IS 2062 justifies that. You have to keep this in mind. In many competitive exams, this has been asked. Partial safety factors for shop welding and field welding is. So for shop welding, the welding can be in a much better control. Therefore, lesser partial safety factor is considered. And in field welding, the control over the quality is less. Therefore, higher partial safety factor is considered. So for shop welding, we generally consider 1.25, and for field welding, we consider 1.5. So answer is C over here. Apart from that, next one, let's see. Which one of the following is the mode of failure in a fillet welded material? So fillet weld actually always fails under shear about the weakest shear plane, which is generally considered as the throat of the cross section of the fillet weld. So if you consider the cross section of fillet weld like this is your fusion face, right? Size of the weld is calculated about the fusion face. This is the size of weld, and you generally consider the highest inscribed triangle inside this particular cross section, and you drop a perpendicular bisector from the root of the weld. This is your root of weld, and this particular dimension which you drop perpendicular bisector, this is regarded as throat thickness. About this particular throat thickness, you would see shear failure happening, right? So the upper portion and the below portion would fail like this, right? Now, if you want to see this in a three-dimension way, let's just consider this triangle only. If let's say this is your effective length, you can consider the failure about this throat thickness and this throat thickness. Connect this. This is your entire failure plane. About this entire failure plane, you would see the shear failure happens in a fillet weld. So this is your throat thickness, and this can be considered as the effective length of weld. Right? This is your effective length of weld, and shear area for this fillet weld will be length of weld into throat thickness. So the failure happens about shear, and the shear area, it is LW multiplied by throat thickness. Let's see the next question over here. In which of the following case we avoid the bolted connection? So connection subjected to fire, connection subjected to frequent earthquake load, connection subjected to snow load, connection subjected to corrosion problem. See, specifically under dynamic loading, we generally avoid bolted connections because of rigidity which is maintained. The type of connection which behaves the best under dynamic loading or fatigue loading, it is the welded connections. Welded connections turns out to be connections with higher efficiency under fatigue loading. So connection subjected to a frequent earthquake load, we can generally avoid bolted connections in that case. Apart from that, let's see this. The effective length of the fillet should not be less than. So effective length of the fillet shall not be less than 4 times the size of the weld. As per IS 800, as per IS 800 2007, the minimum effective length of the weld, it is equal to 4 times the size of weld. right? Size S is the size of felt. S is calculated about the dimension of the fusion phase. Let's see the next question. The distance between centers of the rivet holes should not be less than 2.5 times the diameter of the holes, 3 times the diameter of the holes, 3.5 times the diameter of the holes, 2 times the diameter of the holes. So actually they are talking about the minimum value of pitch or gauge. So minimum value of pitch or gauge cannot be less than 2.5 times actually nominal diameter of the bolt, not the hole, right? So we generally consider nominal diameter for the consideration. Over here holes are mentioned, which is actually wrong. In reality it is the nominal diameter of the bolt. So we can ignore this aspect, we can just ignore the holes part. Apart from that, let's see, the following are the statements about the lug angles used to connect heavily loaded tension members to gusset plates. So we can see over here the length of the end connection is reduced. Yeah, completely correct. When we use when we use a lug angle in a smaller proximity only, more number of bolts can be provided and we can reduce the length of the connection. So it somewhat look like this. So if you want to consider main angle member like this, and if we attach a lug angle in this manner, so this is your connection which you can consider. So this is your main member, and this is lug angle, right? This is lug angle. So over here in a smaller proximity only, more number of bolts can be provided, which reduces the length of the connection. Now, as we are using lug angles, obviously the length is reduced, the length of connection is reduced, the amount of gusset plate required will be less. So the connection becomes economical with respect to the gusset plate requirement. I'm repeating the statement. It becomes economical with respect to the gusset plate requirement. Amount of gusset plate required will be less. Second statement is also correct. The cost of connections increases due to the addition of fasteners and the angle required. Yeah. So extra angle which you need now, which it tend to increase the cost. So the amount of cost which is reduced with respect to the gusset plate is compensated with the increase in the cost of the lug angle which is required. So third statement is also correct over here. So I would say all the three statements, option B is correct. Next comes, which of the following is a type of bolt? So all are type of bolts actually, which are mentioned over here. Option D is the correct answer. Turn bolt, high strength friction grip bolt, and black bolts. All three are the type of bolts only. In roofing sheet, terminology CGI means, so this actually means corrugated galvanized iron, right? This is known as what? Called corrugated galvanized iron sheet. So corrugated means these are what? Corrugations which are considered for roofing sheet material. So these are what? Corrugations which are there, and it is made of galvanized iron. Apart from that, the spacing between two adjacent trusses is known as nothing but bay, right? So if you consider different trusses one after the other, this spacing over here will be considered as bay. This is your span. This is span, and this will be pitch, which represents slope, right? So span, pitch, and bay is the distance between the two. Pitch is nothing but so if you say that this is your front view, you would say that this is slope. Slope is nothing but tan of theta, which is equal to span divided by, h, that is your rise divided by L by 2. So this becomes 2h by L. this pitch over here, it is equal to nothing but h by L. The rise divided by the entire span. So this is nothing but twice of pitch. So you can also keep this in mind that slope is equal to twice of pitch. Right? This is also asked a lot of times. Apart from that, see, the line joining the vertex of the trusses is called as. So if you consider different trusses, so this particular line which will be joining the vertex of all the trusses is known as ridge line. Option A is the correct answer. Afterwards, under what situations will a gusseted base be provided in a column? So gusseted base in a column somewhat look like this. It is generally provided at the base of the column to increase the stiffness of the column or the rigidity of the column, right? And when this particular gusset plate is provided at the base, the rigidity increases, the load carrying capacity also increases. It avoids the crippling of the column at the base. So it kind of increases the area of the column at the base also, right? Generally, when the load applied is very high, and if the load applied is quite high, it is provided, yeah. So column carries a high load. Option D is the correct answer. The beam outside a wall up to the floor level above it is known as. Okay, so they are talking about exterior beams. Exterior beams are the beams generally provided along the boundary wall, generally taking the boundary load or the floor load which is coming outside of the boundary, right? So that is known as a spandrel beam. Exterior beams which is taking the wall load, exterior wall load, or the floor or the balcony which is coming outwards. They'll be taking that load. To ensure the compression flange of the beam is restrained from moving laterally, the cross section must be. So in this question, they are saying that if you want to prevent the beam to buckle laterally, right? If you want that prevention, then obviously you need to provide a lateral support. They are talking about laterally supported beams. But over here, if you want to ensure that full plastic hinge forms and full capacity of the cross section is reaching, then that is possible for plastic and compact cross sections. Option D would be considered as the correct answer over here. Full capacity to develop a plastic hinge, as well as in case of plastic cross sections, you can have the full possible deflections or rotations so that mechanism is formed. Next question, the girders having two or more webs are known as. Generally, it happens in box girders. So in box girders, let's say a welded box girder like this, different plate sections coming together. These two are what? Webs. So multiple webs can be considered, two or more webs can be considered in a box girder. Apart from that, next question, the vertical stiffened web plate of a plate girder, the lesser clear dimension of the parent shall not exceed. This question is from the stiffened web plate girder. So panel dimensions, lesser one, it will be 180 times the thickness of the web, and greater will be 250 times. Now steel contains carbon approximately. So yeah, so steel has approximately 0.05 to 1.75% of carbon, right? Not more than that. We generally do not provide greater than 1.7% because of the fact that it would become highly brittle. And generally, we do not provide less than 0.1 also, because it will be very, very ductile and, that much elongation cannot be adopted. So generally, we keep the amount of carbon content between 0.1% to 1.7%. to have enough ductility also, enough stiffness also, and enough strength as well, right? We also have to keep hardness and toughness in mind. That's why carbon content should not go beyond this. There is one more question which is generally asked a lot, that how much is the carbon content in cast iron? In cast iron, the carbon content is greater than 2% and they are highly brittle. It has been asked multiple number of times in various competitive exams. It is generally varying between 2 to 5%, right? And if you want to bifurcate for low carbon, medium carbon and high carbon steel, for low carbon steel, um, the value of carbon content is between 0.1% to 0.25% approximately. Medium carbon steel, 0.25 to 0.6%, and high carbon steel, it is 0.6 to 1.1%, right? Approximately 1.7% also. Some books have given some values and some books have given some values. So it is not fixed value. It is not a generic value which is given in IS code, but for a range, you can keep this in mind. Apart from that, as I told you initially, standard structural steel, that is your mild steel. That is the grade of steel is what? Fe 410. For Fe 410 grade steel as per IS 2062, the carbon content, as I told you initially, it is 0.23%. So it comes under the category of low carbon steel because of this range, right? So this has been asked multiple times in lower level exams, that is junior engineering examinations a lot. You have to keep this in mind. Next question, the distance between the centers of adjacent rivets in the same row, they are called as, see. So over here, if you provide the bolted connection like this, so this is your bolt line. So along the bolt line, distance between adjacent bolts is called as gauge, and between two adjacent bolt lines, this distance is known as pitch. So distance between the centers of adjacent rivets in the same row. In the same row, you can say along the same bolt line, it will be called as gauge. So option C would be considered as correct answer. Oh, wait a minute. They are saying row, right? So row is nothing but this. If this is your bolt line, or you can say column of bolts, this would be considered as row of bolts. So pitch shall be your answer. Option A would be your correct answer. Next is the distance between the centers of adjacent rivets in the same row. Okay, this is a repeated question, sorry. In the design of connections in steel structures, the distance between the center of any two adjacent fasteners shall not exceed. Okay, so over here, this criteria is very, very important. First of all, there are multiple number of codal provisions for maximum pitch values, but there is one generic IS codal provision in which they have not justified it is for pitch or gauge. In any case, the adjacent distance between the two bolts or two rivets cannot exceed 32 times T or 300 mm, right? This is to be considered for tension, right? For tension members, maximum pitch, compression members, maximum pitch, right? Apart from that, let's see next question. The net section area of tension members equal to its cross section area is equal to. So net section area is nothing but gross area minus the area of the rivet holes. So option D would be considered as the correct answer. The net area which is considered for calculation of design rupture strength of tension members, the net area would be equal to what? Gross area of the cross section minus the net area of the minus the area of the rivet holes. The thickness of single flat lacing shall not exceed. Single flat lacing shall not exceed. So they are talking about single lacing, right? In single lacing system, the thickness shall not be less than 1/40th times length of the inner end of rivets, and in double lacing system it should be 1/60. This has been asked multiple times. I guess it has been asked in engineering services also. The self weight of the steel roof truss in Newton per mm square may be computed by span by 3 plus 5 multiplied by 10. Again, this has also been asked multiple number of times, right? Most of these questions are also from the back of S.K. Duggal book. Yeah, right? You would, if you want to practice basic level questions of steel structures also, what you can do is you can, download PDF of S.K. Duggal. It is, available all throughout various pages on Google. So S.K. Duggal book also, you can download it and just solve the back questions. You would see when you will compare, right, in the previous year questions of SSC JE and RRB JE, many questions have been directly copied from there. If you will consider state AEJE examinations also like MPSC and all, you would see that many questions have been copied from the back questions of SK Duggal. So if you want to practice steel structures, new questions also, some other questions also, what you can do is you can just practice the previous back questions of the SK Duggal book as well, right? So that's it from this particular session, and this is the way in which maximum number of questions are asked in steel structures. Very simple questions they will be asking, very simple codal provisions they can ask, right? Not much complicated questions they can ask you, right? If you want to practice much more questions, best way is practice questions from previous year SSC JE, previous year RRB JE, questions from back questions of SK Duggal you can practice, or there are various other books which are available in the market that also, I also stated that during the introductory video of RRB JE session, when I introduced that we will be conducting live sessions for RRB JE. I mentioned that there is a book which is known as Youth Publications, which is one of the best books out there to practice previous year questions of not only one state but multiple states at one time in a single book. You would find a lot of questions over there, so you can practice from there also. And also you can buy ACE book as well. Previous year RRB JE questions can be practiced from there as well. And you can also practice questions from test series also. So there are multiple number of ways and multiple, books which are available in the market and material which is available in the market, which will help you to practice questions of RRB JE and SSC JE. So thank you very much. If there are questions, please comment down below. I'll respond them personally from my side. Thank you for watching and keep on preparing. All the best.